Alrighty then, corn children. It is another fine day for learning, and this is the highly anticipated volume of revolution washer method part 3. Ta-da! Alright, so this time we are asked to find the volume of a solid formed by revolving the region bounded by y equals e to the x, y equals 1, and x equals 2. So here's our region, and we are supposed to revolve it around a vertical line. Yeah, that's what makes this part 3 extra special. Our line is the vertical line. It's not y, it's x equals 3. So this is the dotted line, x equals 3. All right, if you recall, and hopefully you do, from the earlier videos on the washer method, we have a very strict rule. If the axis of revolution goes one way, the representative rectangles that we draw in must be perpendicular to it. And that is exciting and new. In part 3, when we draw in our representative rectangle, I need you to notice that the small change is vertical. This will be a dy. That teeny tiny little dy is going to change almost everything we do. Yeah, so in the past, when we did our washer method, we had an outer radius squared minus an inner radius squared. Well, that's still going to be true, but because the height of our washer is a dy, these need to be functions of y. Furthermore, our limits of integration will not be x-axis limits. They need to be y-axis limits. So these need to be values on the y-axis. In other words, when we draw in these little rectangles, we need to show with the limits of integration where the lowest to the highest. Yes. So this time, what we've got going on now, from video number 1, we had the washers running this way. Well, now, ladies and gentlemen, our washers are running this way, and we will be stacking the washers on top of each other vertically. Yeah, there's my washer. Okay, so let's get to it. Let's start with our limits of integration. I've taken the time to sketch this area out, and I've included all the points of intersection. Now, when we look at these rectangles, the lowest rectangle would be the, look at it with me, y coordinate, not the x, the y coordinate of 1, not the x, the y. The highest these rectangles will go will be the y coordinate of e squared, found by plugging 2 into this. These are my y limits for this particular problem. Now let's get to the radii. All right, so here I'm going to go ahead and start getting some of this plugged in. There's my limits, 1 e squared outer radius. All right, just like before, for our outer radius, put your finger on the axis of revolution. Put your other finger on the rectangle as far away as you can go. Now, in the past, we did top minus bottom. Now, we're going to do right minus left. My right finger is sitting on the axis of revolution, x equals 3. There's the right, minus the left. Now, I know you're going to be tempted to say, haha, my left finger is on e to the x. Now I'm using a pencil here because this is not going to stay. E to the x. Put that there. It's not right, but go ahead. Put it there for now, but you're going to erase it later. That's your outer radius. Kinda. It's not right. All right. Oh, left. 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 Outer radius, inner radius, minus. Again, inner radius, put your finger on the axis of revolution, put your finger on the rectangle as close as you can get. We are going to do right minus left. The right is x equals 3, the left is x equals 2. This is 3 minus 2. Yes, I'm aware that equals 1, not the point. And this is with respect to y. Now, I am hoping that you see the issue right here. Do you see it? Wrong variable. Remember the dy made a big deal about it like 2 seconds ago. If you forgot, go back and rewind it. I made a big deal. Here's the y. This is not a function of y. It's not a function of y. All of these other values are x equals, x equals, x equals. This is a y equals x stuff. I need it to be x equals y stuff. Oh, how do we do that? We math. This is the equation, y equals e to the x. On the side of my paper, I'll do it right here. On the side of my paper, I need to take this equation and solve for x. How do you do that? Well, hopefully this is not your first math class. It's it's e, so I'm going to use the natural log. I'm going to take the natural log of both sides. No way! Isn't this log base e of e to the x? Those are inverse functions. That's just x. So here's the gig, people. The function y equals e to the x is also the function of y. X equals natural log of y. So now I'm going to take this wrong variable out and replace it with the good variable y. Not a question and answer. Look at it. X equals this, x equals this, x equals x equals. All of these are functions of the variable y. X equals y stuff. The limits are y limits. Yeah? So now we're going to just take this straight to the calculator. Trust me, you're going to want to do this with the graphing calculator with technology. Integrating the natural log of y is a beast. It can be done, but it's not pretty. So let's just check it out. Go to your graphing calculator, type this in. Now, don't round. We need 3 decimal place accuracy, so don't round that sucker. Type in e squared or store the value of e squared and plug in the store. This is the final answer.